Vijay Kumar is our last TEDx speaker for tomorrow to give a demo at his talk. He's a roboticist. I'm trying hard to get this word into my tongue. He does multi-robot formations, and this all sounds like massive amount of fun. So, if you're ready, make some noise, my friends. Also wake up the techs. I think they haven't been sleeping for the past few weeks to get this happening today. I saw the mini eyes here, some sleeping over their keyboards already. Was it enough of a noise? Vijay, how are you?
Yeah, but I wanted to wake them up with a video. But
we're all putting efforts in waking you up, guys.
It's a helicopter with 4 rotors, and you can see that it has a camera in front and a laser scanner that allows it to map the environment and reason about the world it's in and its location inside the world. So robots like this can be autonomous, and in tomorrow's talk at TEDx, I'm going to show you some simple results we've obtained with this robot in creating 3-dimensional maps autonomously, including a map of the TEDx auditorium. Did you get that to work?
Also works great as an event, so if you're hard, come on stage, it's cool here.
So if that doesn't wake you up, hopefully this will. So that video was created by former students of mine, Daniel Mellinger, Alex Kushliev, who are founded a new company called KML Robotics, and their company is about robots like this with multiple rotors, with autonomy inbuilt. And these videos were choreographed to music that was set by Curtis, who is a music producer. As you can imagine, so I'm Vijay Kumar from the University of Pennsylvania. As you can imagine, robotics is what I do. I don't know what questions you have, but the answer is always more robots. So I thought I would spend a few minutes telling you about why I think this is such an exciting field. And although I'm not an entrepreneur, I'm just a college professor, why I think this technology is something that is worth learning about. And in particular in India, given India's rich history in terms of affecting the IT revolution, why I think India should invest in this technology. So let me start off by saying it's not just me who says that this is a powerful technology. If you look at the recent survey, 2013 survey by McKinsey Global Institute, where they list the top 12 technologies, the technologies that are guaranteed to transform life, business, and the global economy. If you look at that list, you will see that advanced robotics, autonomous and near-autonomous vehicles, and 3D printing by extension is also basically robotics technology, all appear in this list. So it is something that you should think about. The claim is that there's roughly $80 trillion worth of impact that this can have in the next decade. So why is it that people think that? Because, again, you look at The Economist, I mean, fundamentally, no matter which country you're in and what kinds of things you're doing, we're short of workers. And robotics is now at a tipping point where, in fact, it can provide the workers that we need. And not necessarily the workers that will be cheaper than humans, but workers that will do the work that humans don't want to do. Look at so this came in Financial Week. This talks about technological investments in robotics. If you look at the first 6 months of 2013, there was roughly $250 million raised, and I think in 2013 I can estimate about close to $1 billion were raised in the area of robotics, small startups, and this does not include big investments by companies like Google and Amazon in that space, and nobody knows how much money they've spent, but it's in several billions of dollars. What I do is a niche in the area of robotics. Tomorrow's talk, my TEDx talk, is on aerial robot swarms, and that's not what I want to discuss here today. What I want to tell you is why robotics has really come to become a promising technology in the last decade. So I'll give you 5 success stories in my mind, success stories in robotics, and a few technological trends that are related to this, which again tie in robotics to the software industry and to information technology, and what I think some of the challenges and opportunities are specifically in the area of aerial robotics. So 5 success stories in robotics, but the first thing I want to emphasize to you that robotics is about 4 things. It's about sensing the environment, it's about communication, it's about computation, and I'll stop here. So what does every one of you carry with you right now that senses, communicates, and computes? A smartphone. The only thing your smartphone does not do is act, right? Right now, you are the actor for your smartphone. You look at the smartphone and you take actions. Now imagine if you could automate some of those things, then you have a robot, right? So that's how close we are to developing robotics that can actually be in our homes and replace the smartphone, or at least augment the smartphones. For 50 years, and by the way, this is roughly when I was born, and I'd love to say that it's 50 years of my life that has made a difference, but 50 years, robots were like this. They operated in industry, and you had a cage like this that prevented the robots from interacting with people, because they are primarily for manufacturing, and typically you had devices like this that locked humans out. The minute you opened the door, you would trigger an alarm and the robot would stop working. Today that's different. Why? So I want to show you this video. This is not our work. This is from the German space agency, DLR. This is a standard industrial robot arm from KUKA, which is a German company. And you can see that the robot has built into it the sensors that will allow it to detect contact and react to contact. So this is a conventional robot arm, and it's the software that allows it to essentially interpret the signals coming from the different motors and very simple sensors, the same motors we've had since World War II. But now it's the software that acts in real time, essentially detecting the maximum torque and detecting collisions where none were to be expected. Sami Haddadin is a very, very creative guy, and you can see he takes some risks because it's his technology. But this is how good this is. And by the way, these speeds are 1 to 2 meters per second. So that's moving pretty quickly. If you go back about 10 years, robots like this might have actually crippled you with the amount of inertia traveling at 1 meter per second. So this is here today. So robots are actually getting safer. Second thing is, when people talk about robots, they talk about co-robots. So I'm going to replace X with co-worker, with co-explorer, or in defense applications, somebody who could help you defend the environment. Or if you're an environmentalist, somebody could work with you to protect the environment. It's not just about safety, but it's about making it easy so that ordinary people can program and train with robots. Again, think smartphones. Not many of us actually do very much with our smartphones. Certainly I'm lazy. I have an iPhone because an iPhone requires virtually no programming, but many of you have Android devices, and all of a sudden you're now able to customize your device to your own needs. Now, robots are getting to the point that ordinary people can actually program and train them. So I want to show you an example of this. This is the Roomba vacuum cleaner. How many of you know about it? Very good. So this is the first generation of the Roomba vacuum cleaner. And this had a user interface that was designed for all the geeks in the audience, right? People who like to program, who like to push things and scroll down lists of menus, tweak these different parameters and so on. But ultimately, because they had to sell it to the people, they came up with a simple interface. So today, if you buy it, there's just one button. And that button says clean and stop, right? Everything else is built into it. The main point I want to make is that industry is transitioning from products like this that are created by engineers to be adaptable, to be programmable, and so on, to products that people want and people want to use. And this transition is pretty significant, and that's why I think robots will enter your home sooner than you expect. This is true not only in vacuum cleaning, but also in manufacturing. So this is the new Rethink robot Baxter. If you look at that robot and you look at its interface, the way you program it is very close to programming a smartphone. Certainly in surgical robotics, robots have made a big difference. So all of a sudden now, from conventional chain it around a light fence, let it operate in isolation, to robots that can work with humans in environments other than just straightforward manufacturing. The third trend I want to point to, and the third success story, is a Kiva Systems story. So Kiva Systems is a company that makes these robots, recently bought out by Amazon. This is a standard warehouse where they have hundreds of robots that are operating autonomously. These robots are networked, and essentially they are filling orders that come in that the human being has to actually try to fulfill. So rather than have a whole bunch of humans fill the orders, what really happens is when the order comes in, a robot figures out where the product is, actually goes, fetches the target pod, and brings the product to the operator, and all the operator has to do is to ship the product. So again, the user interface at the human end is not what I want to draw your attention to, but instead here I want to draw your attention to the fact there are 100 to 1,000 robots that are acting autonomously with the kind of reliability and precision that you expect in a manufacturing setting. This is not one robot, it's not two robots, it's hundreds of robots. So this idea of network robots, sensors, and swarms is also becoming a reality. The fourth thing is it's all about software. So I'm a mechanical engineer, and we design things, we make things, we value the physical side of things. But the value added of most products today, if you take the fraction of it that comes from software, it's a big fraction. Even in airplanes, if you look at the cost of designing a 787, for example, over 50% of the design cost is because of the software. It's also true in cars today, and certainly it's true in robots. So the thing that's changing is there's a lot of open source software now and tools that are available for all kinds of robots. So I'm just showing a whole bunch of industrial robot arms, but it's also true for mobile bases. It's also true for humanoid robots. It's also true for robots that are used by bomb disposal squads. Again, open source software is a way to allow lots and lots of people to play in the field and essentially lowers the barrier to entry. It's not like there's proprietary software that you have to learn before you can get into the field. And there's lots of competitions, as you're probably aware of, that actually encourage even high school students to participate particularly in the US, but also in other countries. So again, this is important in an Indian context because India really made its mark in the technology world in the software industry. And really, if you think about the value added, probably 80% of the value added is due to software, except it's a software on physical things. It's no longer about databases. It's no longer about back-end processing. This is really front-end processing. You have to process it on board. You have to process it in real time. But really, it's about software. So the last thing I want to talk about, and this is a little self-serving, but it's all about moving platforms. So if you look at the history of robotics again, the first 20 years or so, it was all about robots that were bolted to the shop floor. They were stationary. The next 20 years, you saw vehicles with wheels that were autonomous. But this past decade and the decade after is about vehicles that go up into the third dimension or vehicles that go down underwater. If we had robots like this, if underwater robots had the same level of maturity as ground robots today, that Malaysian airline flight would have been found in 24 hours, right? So I think this is, again, if you were to invest if you want to pick one technology to invest in this space of robotics, it's got to be underwater. We know more about outer space than we know about our own oceans. And the reason is we don't have enough robots. I told you, whatever the question is, my answer is we don't have enough robots. So now there are conferences on autonomous vehicles, and there are conferences on autonomous aerial vehicles, conferences on autonomous underwater vehicles. And the last thing I want to point to is manufacturing. So if you look at manufacturing, and you can walk into any manufacturing plant in any country, and chances are you will see different levels of automation, not based on which country that plant is, but based on what kind of products you're looking at. So I have here 3 sample products. So this is a car, this is a plane, and this is a smartphone, right? And if you look at the level of automation, right, it's maximum in a car, somewhere in the middle in a plane, and the least in a smartphone, right? So why is that? So a friend of mine who works for Motorman, which is a robotics company, took up this challenge, and he asked himself, is it possible for an industrial robot, this happens to have 2 arms and has a camera, is it possible for this to assemble smartphones? Actually, what it's assembling here is a digital camera, but if you can assemble a digital camera with a robot, you can also assemble a smartphone. And he showed that, in fact, it's possible to do it, right? So this is a Japanese robot assembling a digital camera with virtually no human intervention. So why is this that we have only 10% automation in the smartphone industry? Can anyone guess? You're close. It's about time. It's not about labor. It's about time. What's the life cycle of a smartphone? At most. I would say 6 months. In my daughter's case, it's probably 6 weeks. So if you have a 6-week or a 6-month life cycle, there is no way you can set up a machine like this and program it to manufacture smartphones. So what's the problem with that? It's about software. If you can develop software fast enough, if you can train robots, and again, it's all about software, if you can do it fast enough, in a time that's comparable to the life cycle of the product, so the life cycle of the product is 6 months, you have to do it in 6 days. If it's 6 weeks, you have to do it in 6 hours, right? So if you can do that, then all the manufacturing can be done in any country independent of the labor costs, right? So the picture you have today is really a sad commentary in the state of technology, not because labor is cheap in some countries and not in other countries. So those are sort of 6 things that are happening, and how much time?
We're a bit over time, but
okay. That video went too long. This is far too much more interesting, I think. So let me just quickly breeze through a few other things you might want to think about. TechCrunch had this really interesting article. So today, hardware is like the new software. If you think about the design, prototyping, testing, redesign cycle, that's getting faster and faster. I know in India, there's a lot of emphasis now on Make in India. Well, that's actually become easier. And hardware is becoming like software. So it should be possible to do that. So I think that's a great opportunity. Second, I can say the rate of X, whatever X is, whatever that X is, the rate is increasing. Right? You think about making things, the rate at which you can design and make things, that rate is increasing. You think about developing apps, do-it-yourself things, with crowdsourcing and so on, that's accelerating. For materials, the time to take to discover, synthesize, and develop new materials, that's increasing. So that's a trend that's important. The third trend I want to point to is the trend towards the industrial internet. And here's my, again, take on history. The 18th century saw the Industrial Revolution, and people would debate this, but the next big revolution happened because of the transistors and the internet revolution, and I think India was a big part of that. The next revolution that's going to happen is something that couples the physical systems and the cyber systems, and that's the cyber-physical revolution. And that's what, if you're an entrepreneur, that's what you want to be engaged in, and you got to place your bets on. Great implications. Lastly, I'll just say everybody complains about computing. Well, computing is slowing down. Moore's law is over. But there's the after party. You look at the computational cost. It's still decreasing at about 30% annually. You talk about storage costs, again, 38% annually over the last 2 decades, and this continues. Same thing true with bandwidth costs. So in the context of robotics, it doesn't matter where the computation is done because you can communicate. It doesn't matter where you store your data because you can retrieve it anytime you want. And that has given rise to this notion of cloud robotics. So I want to show you robots that exist in manufacturing, that self-driving cars, surgeons, military aircrafts, although these are not robots, but let's pretend they are. And the fact is, computation is not done just on the robot. It's done on the cloud. There's lots of things being done locally, but the expensive computation and the storage is done on the cloud. So when you go about cyber-physical systems, you really have the opportunity to decide where computation should occur and place it optimally. So that's something that's also, that trend is also accelerating. And then finally, I'm going to leave you with one last thought, which is, today it's about the 3C industry that's really revolutionized a lot of consumer electronics. The falling price-performance ratio of computation, communication, and it's impacted all kinds of industry. And I want to show you, leave you with one last video that illustrates how the 3C industry and flying robots have actually come together. So this video shows an off-the-shelf robot with no smarts and a smartphone sitting on top of it. The smartphone is gathering data about the environment, and the robot is doing the acting. So remember in the beginning I said that this guy is capable of doing the sensing, computation, and communication, and the robot in the bottom, and think of it as just 4 motors and 4 propellers, and that's it, right? It's something that you can make at the barrier to entry for that is nothing, right? You can just buy these things off the shelf and put it together. Well, if you integrate with a smartphone, suddenly you have a robot that's capable of functioning autonomously. So Giuseppe, the student, the postdoc here, is essentially driving the robot by giving it high-level commands, presumably through another smartphone. And the robot interprets the commands and is able to infer its position in the environment. And this happens to be our lab, by the way. And this is a straightforward piece of integration, and Yash was involved in this. The biggest challenge for our integration, and Yash, you should correct me if I'm wrong, is finding a USB cable that was short enough to plug these two things together. And everything else was software. So my main point is, and I'll conclude with this, that the software industry that I think India is so well known for, and the robotics industry that India is not that well known for, are not that far apart. And wouldn't it be great if India were to play a major role in robotics? Thank you.
Thank you very much. So it's time for the Q&A, and I start with the first question. I think it was last year at TED in Long Beach when Chris Anderson asked the audience how many of you would have a robot at home. So how many of you has a bot at home? So at TED, it was like 3 hands down, and then the rest was up. So what's your best guess? Let's look at the glass bowl. How long does it take until all the hands are up?
Well, I'm 53. When I'm 75, I'm convinced I'm going to be living with more robots than human beings, right? It's not like I'm going to have lots of babies and grandchildren, but I'm going to have lots and lots of robots. Yeah. And I think the technology will be there, and as we age as a society, we're going to need these robots.
Thank you. First question, first row.
Yeah. So far in business, you see companies like Amazon that are huge, have all these robots in warehouses. What about smaller businesses? Can a robot maybe solve my HR problem if I want to fire my secretary and just get someone more productive?
I think it's a mistake to think about robots as replacing people. I think the thing you have to ask is, what is the robot capable of doing that a human either cannot do or will not do, and more often will not do? So the question you have to ask is, what are machines that are synergistic and complementary to humans? And most robots are superhuman along some dimension, and they're very dumb along the human dimensions. And that's the synergy you want to look for.
What about the cost? I mean, can a smaller business afford these sort of robots?
I think, like I said, there's a great quote by Chris Anderson, not the TED Chris Anderson, but the guy who does DIY drones, who was the editor for Wired magazine. He basically said that robots are the dividends